Hi there, and welcome back. What we're going to do in this video is find a limit of a rational function, well, not quite a rational function, 2x plus 1 divided by the square root of 9x squared plus 1. And what we're going to find is that we can use the technique that we already know, which is dividing by the highest power in the denominator, but we have to be really creative on what we do here. So looking at the denominator, it has a square root, and the highest power under the square root is x squared. So I'm actually going to divide everything, and what I mean by everything is the numerator and denominator, by the square root of x squared. Now, that's going to come in two forms. Remember that the square root of x squared is equal to x as long as x is positive. And since x is going to infinity, we are very certain that x is going to be a positive number. So what I'm going to do is I'm going to divide the numerator by x, and I'm going to divide the denominator by the square root of x squared. And that's so that the square roots align and the non-square roots align. So looking at that expression now, we have some simplifying to do. So this is equal to the limit as x approaches infinity. Now 2x plus 1 all divided by x is really 2x divided by x plus 1 divided by x. And in the denominator, we can now combine those square roots as 9x squared plus 1 all over x squared. So now this is looking a little bit better. In the numerator, I'm going to go this way. So we have the limit as x approaches infinity of 2 plus 1 over x. I'm going to keep that in parentheses, divided by, now in the square root, we really have 9x squared over x squared plus 1 over x squared. So the x squareds are going to cross out and leave us with a 9 plus 1 over x squared. Great. This is already looking better. And you notice at the top here, I wrote down the property of limits that's the most useful here. Limit as x approaches infinity of some constant divided by some positive power of x is always equal to 0. That denominator continues to grow. The larger the denominator, the smaller the actual value of the expression. So one last thing we'll do is I'm going to rewrite this as the limit of the numerator. It's easier to look at one thing at a time, of 2 plus 1 over x divided by the limit in the denominator, square root 9 plus 1 over x squared. So now the limit of the numerator, well, as x goes to infinity, 1 over x, whoops, didn't mean to erase it, even though it kind of does erase. 1 over x does go to 0. And as x goes to infinity, 1 over x squared goes to 0. So we essentially have the limit of 2 over the limit of the square root of 9. Those are just constants. So this limit is equal to 2 over the square root of 9, which is 2/3. And there's our limit.